you see, as they have pointed out in this left-hand side of the slide, these different architectural types of an agent, the table-driven, simple reflex, model-based reflex agent, goal-based agent, and utility-based agent, they are more and more sophisticated variants of the agent architecture. Okay, they all strive to implement the same thing, P star mapping to A. But how they do it, depending on that, or how sophisticatedly manner they do this particular mapping, is what makes them different from each other. Okay, so saying so, all these agents will have this kind of similar composition of their agent program, but there may be extra steps. Somebody is doing something good at initial step, somebody is doing something else at the end of the mapping. So this is the mapping. This is the things that we do before we do the mapping. These are the things that we do after we do the mapping. So every agent architecture will have its own variant of this particular skeletal agent. Okay, so let us now go and see them one by one. So this is the table-driven agent. Now in table-driven agent, we are actually having this particular static variable called as percepts. This is the way of table-driven agent to remember the memory. So हमने देखा था ओरिजिनल एजेंट का जो स्केलेटल आर्किटेक्चर था या स्केलेटल प्रोग्राम था उसमें मेमोरी नाम का एक ही स्टैटिक वेरिएबल था. Now there are two static variables. One is called as percepts and there is a table driven agent नाम ही है. So we have to have this table. Now what is this table? This table is a table. It's a 2-column data structure that is indexed by percept sequence, and initially it should be fully specified. That is, for every set of percept sequences, I should have what action the agent should do. So it is a pre-represented or a pre-configured table. Okay? अगर रियल वर्ल्ड सिचुएशन इतना ही सिंपलिस्टिक होता कि मैं एक टेबल बना सकता जिसमें I have indexed as percept sequence and a corresponding action, then इससे अच्छा क्या होता. बट हमारे रियल वर्ल्ड सिनारियोज में इतना इजीली हम लोग ये पर्टिकुलर टेबल प्री कॉन्फ़िगर्ड नहीं कर सकते. ये जो वर्ड है फुल्ली स्पेसिफाइड, इट मीन्स फॉर दिस एजेंट टू वर्क आई शुड हैव नोन ऑल द percept sequences. And we think of that particular example of a vacuum cleaner world where there were only 2 cells and a vacuum cleaner was there, autonomous vacuum cleaner was there. Even that simplistic scenario also, we concluded that it won't be possible for us to know all the percept sequence ever in advance. So if we are not able to have all the percept sequences known in advance, we will not be able to construct this table. And as we will not be able to construct the table, it will not be possible for to realize as this agent program. ये agent program realize करने के लिए ये table fully specified होना चाहिए before the agent starts operating. The only thing that you are changing is this percept sequence. So percept sequence initially empty होता है, पहला percept आएगा, we just update it into percept sequence. You are just appending percept to end of percept sequence. So percepts is implemented as a list of percepts that I see one by one. Okay, it's a list, but it's an organized list. It's a ordered list, I should say. So the earliest percepts are at the bottom, recent percepts at the top, and you can do a lookup using these percepts into the table because percepts represent the percept sequence. Table represents percept sequence mapped against an action. So this is most simplistic thing, but most unrealistic one as well. What is the problem? Huge number of possible percepts. Consider the amount of taxi with cameras and sensors. So हमने अलग example लिया था. वो इसका example लिया था. Vacuum cleaner world with 2 rooms, and that also had infinitely many percepts. So as the percepts are infinitely many, we will not be able to enumerate all of them. Since we can't enumerate all of them, we won't be able to enumerate all the correct actions corresponding to those percepts. Hence, This is not possible. But this is most ideal, and this an agent based on specified lookup table. It keeps track of percept sequence and just looks up in for the placed action. So it will work very fast. If I am able to ever produce this table, it is going to work very fast. Okay, it is going to render me accurate action because I must have done all the due diligence in preparing this table to give away the right action for every percept sequence. Okay, the issue is to come up with such table. It's highly unlikely for an ideal or a real world scenario. For a abstract scenario with a very much restrictive definition of the world or the environment, this is always possible. This is always possible. But then still it's not going to be a useful one. Okay, so that's the first architecture for you. It's called as table-driven architecture. There's some discussion of newer textbooks and other things. They will not consider table-driven agent as an agent architecture. They will say that table-driven agent is just a assumption. That's the ideal assumption looks like. So they won't say that table-driven agent is actually agent architecture. They say that it's something that we vouch for, or it is something that we want but won't get. Okay, so that is about certain books, but I personally also feel same with what this particular instructor feels. Table-driven agent should be the first agent architecture or the simplest agent architecture to map P star to agent because it is doing precisely that. From the current percept, it is adding it to the percept sequence, which was previously remembered in the static variable percepts to produce a percept sequence till date. Using that percept sequence, it is doing a lookup and getting a mapping for the corresponding action. Okay, so that's ideal behavior, ideal thing which mathematical function wants us to do. P star map to E, exactly what we are doing. Okay, so that's why it is ideal one. Okay, again, this is also a kind of thing that people feel is a drawback of this agent architecture. Since table is pre-configured, if the scenario changes, if the environment is adapting, and according to that, my sensors and other things are being remain the same, I will not be able to judge the state properly, and then I may not be able to adapt accordingly. अगर adaptive अलाउ करता है तो टेबल ड्रिवन एजेंट नहीं रहेगा क्योंकि टेबल फिक्स नहीं रहेगा. ओके, सो टेबल फिक्स्ड है इसीलिए ये अडेप्टिव नहीं है. सो नॉट adaptive to changes in the environment requires entire table to be updated if even smaller changes occur. If even smaller changes occur, you need to update the entire table. Okay. Now, the alternative to this is a simple reflex agent. This works on the fact that even human beings show the reflexes. Okay, this differs from the lookup table based agent in that there is a component called as condition action rule. So instead of a table, we create a box called as condition action template or condition action rule set. Okay, is already higher level interpretation of percept. So percept ना करते हुए हम लोग condition action rule की तरह उनको represent करते हैं. तो जैसे ही मेरे पास percept आएगा तो उस percept को मैं convert करूंगा एक situation में जो situation query करेगा condition action rule sets. So condition action rule set is like if else kind of a construct. So if this happens, I'll do this action. Otherwise, I will do this action. Otherwise, I'll test if this other scenario occurs. So it's like a case statement in any programming language. So you define the different conditions, and if the situation at hand maps to a particular condition, you get a certain rule out of it, and you apply that rule for taking the action. So that is what condition action does. So percept could be the pixel on the camera of the automated taxi. There are a lot of examples like that.